Alright, let's go back to slice 1. Good old FTP. One of the biggest advantages of FTP is that it is already available in so many places. Windows, Unix, Linux, ZOS, you name it, usually comes with FTP ready to go. The client side is always ready to go out of the box, and usually there's a server side that's pre-installed, just waiting for some configuration information. You'll be off and running. Since it's been so readily available for so long, you've all probably had some exposure to FTP. It's pretty simple to use, follows some common protocols we're already familiar with, and has a nice basic syntax for the fundamentals. In addition, since FTP's been around for so long, and no one wants to really be left out, it usually comes with all the appropriate extensions to make it work well on the platform that it's delivered with. For example, the ZOS FTP server and client handle MVS datasets without skipping a beat. EBCDIC to ASCII conversion is ready to go, and even JES support is available for submission of jobs and extraction of reports. But as Colin will demonstrate, FTP doesn't really handle privacy and security very well. FTP is a clear text protocol. Any eavesdropper on the line can see user IDs, passwords, the data files themselves. In a closed, secure environment, that can save a lot of hassles, but that type of inherent guarantee is more the exception than the rule in today's networking environments. To address networking security issues, there have already been lots of precautions taken, such as firewalls. Firewalls are intended to let safe traffic pass while blocking suspect connections. Good plan, but difficult to implement, particularly when it comes to FTP. FTP is a strange protocol because it was designed around having two connections, one for commands, which is the initial pathway, and a second for data when transfers are underway. This diagram gives a basic idea of what a standard active FTP session might look like. The client requests a connection to the server, the command session, and the server opens a data connection as necessary to transfer data between the partners. The FTP protocol was designed around a trusting relationship. Both participants in the communication were oblivious to the rest of the world. But as the world got to be a more open, less safe place, precautions were put in place. A conventional approach was to place a firewall between the intranet and the rest of the world. Those on the inside were trusted, so were given permission to talk to whoever they liked. But those on the outside were not permitted to start the conversation with someone on the inside. That caused a problem for an active FTP session. So what happened was that the initial command connection would work fine, but when a transfer started up, the firewall would block the new connection coming in from the outside. So a passive mode was added to help deal with this security problem. So in passive mode, the client would indicate its intention to the server. If the FTP server was configured to support passive mode, the server would start a listener on an ephemeral port, which is a dynamic port grabbed from a pool of available ports, and pass the port number to the client on the command connection. The client could then initiate the second data connection, and the firewall would allow the transfer to work. Basic firewall setup now worked, but sometimes this basic setup was not as secure as might be desirable. Limiting access to the outside world can be desirable for businesses in many cases. This could cause a problem for the second connection on the ephemeral port, which was not defined as an acceptable port to the firewall. So firewalls are enhanced to sniff the port number being passed on the command connection to provide temporary access from the host to get that data connection working. Okay, so another band-aid was added to fix the boo-boo. But this will become a problem in a moment when we start talking about FTPS. FTP did not make any concession for improved network performance either. Compression was not native to the FTP protocol. There is a Mode Z extension that is available in some implementations, but you can't always count on it being available. FTP also did not provide any application-level checksum to verify the integrity of the data. It relied on the TCP checksum, which provided some minimal checking, but was easily fooled. For example, a transposition of the bytes in a packet could provide an identical checksum, fooling the integrity check. Network reliability has come a long way, but it's still not flawless. If you need to know the data was transmitted accurately, FTP does not provide the level of confidence that you might desire. FTP can still be useful when privacy and integrity are less important than easy access. For example, if the data is public knowledge and there is some room for inaccuracy, FTP might make good sense. Since FTP is familiar and already available in most cases, it can be used effectively. You might want to consider its usage whenever what I'd call an anonymous test would be deemed appropriate. First of all, anonymous access would indicate little need for confidentiality and a limited need for accuracy. Second, anonymous also means authentication is not important. Keep in mind that native FTP means not only data, but also user IDs and passwords are being sent in the clear. So anyone sniffing the traffic might be able to get access to information that you might consider confidential. You may also want to use it on the internet because it's already available and well known. But keep in mind that user IDs and passwords are easily sniffed using tools that are freely available in the internet. A quick internet search for data theft by employees might be an eye-opener. Statistics as high as 80% for data theft being perpetrated by employees can easily be found. Intranet or internet, I'd still consider using anonymous test that we just talked about before using FTP. So in the end, far too many things are still being done via FTP, and a review of what really is going on is very often the best place to start.